Good morning, period 1, algebra 2. I know you are missing me this week, but it is like I am still here. So ladies and gentlemen, I am going to record a lesson for you on lesson 2.3. We're talking about histograms and percentile rank. So you should be opened up to this page in your packet, which I believe is page, let me check here. I believe we're on page, I can't even find it. We are on page 10 in your packet. So, to start out, I'm going to give you a few quick definitions. A histogram. A histogram is a type of graph. It's a graphical representation of a data set with columns to show how data is distributed across different, and the key word is intervals of values, across different intervals of values. Students often get histograms confused with what are called bar graphs. You probably made a bar graph when you were younger. Maybe you were in first or second grade and you surveyed your class what their favorite food was, and 10 people said it was pizza, and so you were able to make a bar graph that showed the category for pizza, and it would be 10 units high. We're going completely different, though, with the histogram. Histograms have what are called bins, and the bins always represent how many things fall within that interval. And the more things you put into a bin, the higher the bin is going to get. So if we compare a bar graph and a histogram, they're easy to confuse, but we're going to try very hard not to confuse them. The bars of a bar graph always indicate categories. They are usually non-numerical. So for instance, if we're comparing student eye color, and we have a few different eye colors on this graph. We have black, blue, brown, green, hazel. Black, blue, brown, green, hazel are not numerical representations. Those are what are called categories. Those have nothing to do with numerical representations. They are categories. You could not have a range from black to blue, from blue to brown, from brown to green, from green to hazel. You either have those eyes and there's really nothing in between. But student height is a little different. Student height is numerical. This is a numerical representation, and this is non-numerical. If it is numerical, it wouldn't make sense to make a bar graph, one for a height of 155, for a height of 156 centimeters, for a height of 157, 158, 159. It doesn't really make sense to do that. Instead, you are going to do an interval. These are intervals. And I am always going to want you to do bin right for your intervals. What the heck do I mean by bin right? Bin right means that the value 155 always goes in the bin to the right. The value of 165 always gets placed in the bin to the right. If you're not consistent and say you put 165 sometimes to the right and to the left, it could really skew your data. So I always want you to go bin right, put the values on the boundaries to the right always. And that's kind of what this statement means right here. Numerical versus categorical. You'll see that the histogram, there are no spaces. There's no space between bars because the intervals are right next to each other. There's no space between the bars. Here, generally, there are always going to be spaces for your categories. So please make sure that you pay attention to the differences between a bar graph and a histogram. To be honest, a bar graph is a little more elementary, but a histogram is a little more higher level, high school type type thing. Benefits of a histogram. A histogram can show overall shape and distribution of a data set with larger bin widths. But if you adjust the bin widths, it can also show gaps and clusters in a data set with smaller bin widths. So a histogram can give us kind of an idea of overall shape. If we look at our overall shape of this last histogram, you can kind of see a nice little bell curve, which you would kind of expect for student height. There would be students over here that are kind of shorter, students over here that are kind of taller, and then the students in the middle, or we're closer to what the average is, okay? Histograms, just looking at a histogram, though, one of its downfalls is you don't know the data. So I have no idea what data points are inside of each of the, I have no idea what's inside those bins. I just know that in this bin, there are a total of 2 data points. In this bin, there are a total of 6 students from the height of 155 to 165. And here there are, I guess, is this about 11? Looks like 11 students from a height of 165 to 175. And finally, 3 students from a height of 175 to 185. You don't know what the actual heights are, but you know how many students fall in those ranges. And that's one downfall to a histogram. Skewness describes how data is distributed relative to the center. We could use histograms and actually box plots to take a look at skewness. Symmetric would be something that we would describe as a balanced or close to balanced data set. And then finally, once again, skewness, which I guess really I wanted this to be shape, so maybe we can change this word to shape. You're probably going to be mad at me because I'm making you erase, but I think I want the better word shape up there. Skewness describes data that's spread out a little more from one side to the other. So if we have what's called skewed right, that means the data is more spread on the right, as opposed to what's called skewed left, which means that the data is more spread on the left. A lot of times students think that when data is more spread on the right or the left, it means that there's more data there, and that's not necessarily the case. It means more so the data is more spread out on those values. So I have a few shapes here for you to look at. This we would call symmetric. It's pretty balanced. You might also use the word balanced here. The reason why it's balanced is because the whiskers are about the same. The box sides are both about the same. It's a nice symmetric, and you know what the word symmetry means, and symmetry is usually pretty easy to pick out. But this we call skewed right. Over here, we're skewed right. And the reason why we're skewed right is because the data is more spread out on the right-hand side than on the left-hand side of the data set. So we would call this a skewed right data set. Over here, we would call this one a skewed left data set because on the left-hand side, we are way more spread out on the left-hand side. Way more spread out. You can see that also in histograms. We would call this a very balanced and symmetric histogram, while this one would be skewed left because it kind of tails off and it's a little more spread out to the left. There's more spread on the left here. As opposed to this one, which if you kind of draw in your little shape, this one tails off and is more spread out on the right. There's a little more spread on the right. So I need you to be able to look at a box plot, look at a histogram, and decide what its skewness really is. So if I ask you a few questions here about two different histograms. To find the range of the data, you would simply do max minus min. Now, you wouldn't be able to know that by looking at this histogram or this histogram. In this particular data, we're looking at a random sample of 50 students who own iPods, and they were asked how many songs are on the iPod. So we have a nice list of how many songs are on each iPod here. You would take your max minus your min. I think that the max is 1,013, and you could subtract off your minimum value. Minimum value, I'm guessing, is something like 765. Are there any smaller than that? I don't believe so, but I'm checking. I hope that I'm getting this right here. 765. Yeah, I think that's the smallest. I'll leave you to subtract on your own. What is the bin width for each graph? We have graph A and we have graph B. Take a look at the bin width. How wide are the bins in graph A? Look at that interval. For graph A, it's 50 songs. But down here for graph B, they're much smaller widths, only about 10 songs total. We know that Susan surveyed 50 total students overall. You could count to make sure that there are a total of 50 students, but how can you know that the bar graph, or not the bar graph, the histogram, accounts for all 50 values? You would simply sum the bin heights. What do I mean by bin height? Well, for instance, this one has a bin height of 4. We have a bin height of 6. We have a bin height of 13, and a bin height of 18, and a bin height of 7, and a bin height of 2. Double check for me right now. If I add up all of those bin heights, do you get 50? You should get 50. Why are the columns shorter in graph B? Graph B, if you notice, the bin heights aren't nearly as big as they are in graph A. Well, in graph B, the bin heights are shorter because the bin widths are smaller. That kind of allows you to see gaps and clusters in the data. You can see a gap here, a gap here. We've got some clustering going on right here. So when we're asked the question, which graph is better at showing the gaps and the clusters, it's definitely graph B. But when we're asked which shape is better at showing overall distribution, I would definitely say that it is graph A. Take a look at graph A, and I want you to draw this in graph A. Graph A, you kind of see a very nice overall distribution. What is that shape? I'd actually say that that's pretty close to being symmetric. And my last question, what percentage of the iPods have fewer than 850 songs stored? Well, we could count up how many of them have less than 850, but we could also take a look at our histogram. Here is 850 at the histogram, and everything below it is this bar and this bar, which is a total of 10 values. If I would count up the values less than 850, there'd be a total of 10 of them. So the percentage is simply going to be 10 out of 50, which equals 20% of the data. So this is a little mini lesson on histograms. I hope you got the main idea about the difference between a histogram and a bar graph. And right now you're going to complete an independent assignment. I'd like you to flip the page over to page 14. I'd like you to do numbers 1 and 2. Just part B. I'll teach you about percentile when I return. And you'll also have for tonight a separate handout on lesson 2.3 as well. I will see you on Thursday. Feel free to rewatch this video. I'll post it to your dashboard if you need to go over any other additional topics or definitions. Have a great day.